To determine if a planet can give birth to life, it must meet three basic conditions: a stable geological structure, a suitable climate, and core chemical elements are essential. Recent Mars probe data, unusual geological traces, and element ratios defy solar system norms. This suggests a startling possibility. Hundreds of millions of years ago, Mars was Earth's mirror image. It may even have been habitable earlier than Earth. Mars and Earth formed from the same primordial material, resulting in similar geological structures. InSight lander data shows Mars' crust is 24 to 72 kilometers thick. This indicates early Mars experienced significant geological activity, including widespread volcanism. These movements were key for creating chemical cycles necessary for life to emerge and sustain itself. The planet is covered in impressive volcanic relics, like Olympus Mons. This supervolcano erupted intermittently for hundreds of millions of years. It released enormous quantities of carbon dioxide and water vapor, building a substantial atmosphere. Mars also displays dramatic water-formed landforms, like Valles. This immense canyon system resembles scars from ancient mega-river networks. The Jezero crater delta was once a large lake, fed by multiple rivers. It carried sediments, minerals, and organic compounds, ideal for primitive life. Hundreds of millions of years ago, Mars was not the cold, dry world we see today. It possessed vigorous geological activity and abundant liquid water systems. These provided a solid foundation for life to develop and flourish. Today, Mars' surface averages minus 63 degrees Celsius with a thin atmosphere. This prevents surface liquid water, but it's a degraded state after billions of years. Research shows that hundreds of millions of years ago, Mars had a warm, wet climate. Scientists found widespread minerals formed only in liquid water, like clays and carbonates. Hematite requires prolonged, cool liquid water, proving stable surface water once existed. Mars' northern plains span 16 million square kilometers, perfectly flat and lower than the south. Scientists suspect this was once a massive northern ocean, possibly over a kilometer deep. Early Mars had a strong magnetic field, shielding its atmosphere from solar wind. Volcanic carbon dioxide created a greenhouse effect, maintaining temperatures for a full water cycle. Carbonates in Gale Crater confirm wet-dry climate cycles favorable for microbial life. Why did this habitable climate suddenly collapse? This is the Martian civilization mystery. Conventional theory blames the magnetic field weakening around 4 billion years ago. This allowed gradual solar wind stripping, but probe data shows faster atmospheric loss. Roughly half vanished in a short geological period. This anomaly fuels the nuclear war hypothesis. Life requires carbon, hydrogen, oxygen, nitrogen, phosphorus, and other key elements. Mars possesses them in abundances and distributions, closely mirroring Earth's. Curiosity detected rich organic carbon in the soil. Jezero crater mudstone layers contain iron phosphates, iron sulfides, and organic carbon. This combination is often linked to microbial metabolism and a strong biosignature on Earth. Mars' red color comes from abundant iron oxides, hinting at modest early oxygen levels. Liquid water has been detected in deep rock layers underground, potential refuges for life. Ancient Mars had every condition needed for life to arise and thrive. If Earth could birth life, Mars had no reason to be an exception. Life there may have begun hundreds of millions of years before Earth's, and could have evolved into a technological civilization comparable to or surpassing our own. Since the 1970s, probes have uncovered puzzling anomalies on Mars. Isotope ratios, unlike the rest of the solar system. Surface glass, resembling nuclear blast residue, and atmospheric gases linked to nuclear reactions. Particle physicist John Brandenburg proposed a dramatic hypothesis. Hundreds of millions of years ago, Mars suffered two massive nuclear explosions. These destroyed any civilization, leaving anomalies as lasting scars. All solar system bodies formed from the same primordial nebula, so isotope ratios should be consistent. Yet Mars deviates sharply, especially with elevated xenon-129. This inert gas is rare and mainly produced by nuclear fission or fusion. Mars' atmosphere has 2.5 times more xenon-129 than Earth's. Its xenon isotope ratios closely match Earth's nuclear test sites. Brandenburg argues these cannot be explained by natural processes. Mars additionally has high uranium and thorium concentrations. Nuclear blasts on Earth create glass by heating sand to tens of millions of degrees. Similar silica-rich glass deposits on Mars align with xenon-129 zones. Forming such glass required energy equivalent to roughly 100 million billion tons of Ti. Early Mars had a thick atmosphere. Today it retains less than 1%. Brandenburg suggests nuclear explosions caused the rapid disappearance. This triggered a nuclear winter via massive dust. Though the hypothesis sounds like science fiction, evidence suggests natural processes alone cannot account for all anomalies. First, the required energy vastly exceeds natural limits, with no giant impact crater. Second, anomalies are tightly concentrated and correlated in northern regions. These patterns are characteristic of nuclear explosions. Third, neutron air radiation traces are confined to surface rocks, leaving deeper layers untouched, exactly as expected from atmospheric air. Together, these create a unique nuclear fingerprint, including distinctive xenon isotopes. Latest data even suggests microbial life may still persist in protected mid-latitude ice layers and underground lava tubes, possibly forming ecosystems different from Earth's. After reviewing this evidence, can skeptics honestly call extraterrestrial life mere speculation? The red planet may conceal one of the solar system's greatest tragedies, a once thriving world, perhaps with a technological civilization that destroyed itself in a cataclysmic nuclear war, forever changing its fate.